Welcome to math classes. Today we'll learn the 3D dimensional geometry. Okay. So in NCERT class 11th, 3D geometry is a very small chapter actually. And in class 12th also you have a 3D geometry which is extension of class 11th. So I want to cover both class 11th and class 12th continue and cover the class 12th also. 3D geometry, complete 3D geometry is going to be here. Okay. So first I will look at the class 11th syllabus and solve the exercises, then go to class 12th and solve the exercises. Okay, let's do it. Yeah. What we are going to cover is coordinate axis in a space, octants, what is the coordinates of a point, distance equation, and then exercises. Okay, and then the green part is the class 12th 3D geometry part. Okay, which is direction cosines and direction ratios, equation of a plane, equation of a line in a space, angle between two lines. Okay, exercise and miscellaneous exercise. Okay, these are the things we are going to cover in this complete video. Okay. So what is coordinate axis in a space? Okay, normally we are looking at the two-dimensional space where x and y are there axis which are perpendicular to each other, and you have a point where x comma y. Okay, and if you want to understand the 3D coordinate system, you look at the room corner, top corner, the top corner or the bottom corner you can look at. Okay, then you will understand what is your three-dimensional space. Okay, in xy plane you cannot tell at what level it is. Correct. In a three-dimensional space you can tell what level you are in. Correct. If you are going on a road and using Google Maps, okay, if you are going on a plain road, it will show you a road which you are going. If there is a flyover on top of it, okay, it is very difficult for Google Maps to show the route whether you are going on top of flyover or below the flyover. Correct. So still Google Maps has not solved this problem. There are some maps are there which are three-dimensional, but otherwise two-dimensional maps cannot solve the problem of flyover if you are going on the flyover or below the flyover. Okay, this problem cannot be solved. So 3D geometry is going to talk about three-dimensional space. This is most important. Okay, so three coordinate planes will be there: xy plane, yz plane, and zx plane. Three planes you will get. Okay, and consists of three mutually perpendicular axes which are x, y, and z axis, and this will divide the space into 8 regions. Okay, what are the 8 regions? We'll see. Okay, they are called octants. Okay, now I said xyz plane divides the space into 8 regions. What are the eights? You can see here how it looks, those eights. Okay, you will have positive, positive, positive. All xyz are positive, correct? So each one has positive or negative. You have three boxes basically xyz. Each box has either positive or negative, two options. So 2 into 2 into 2, you will get basically 8 options. Correct? What are those 8? Plus plus plus, minus plus plus, minus minus plus, like this. Okay, you will get all 8 options here. But how to remember the number of which one is what octant? Okay, it is very difficult, right? And they are not in any order. That plus 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 and then minus minus plus, very difficult to remember this. So how they did is basically you ignore z. Okay, look at x and y. X and y, we know what is the coordinate system. Okay, both are positive, it's called first quadrant. Okay, x is negative, y is positive, we call it second quadrant. Both are negative, x, y are negative, we call it third quadrant. Okay, and x is positive, y is negative, we call it fourth quadrant. Now you put just plus to this one for the first four quadrants of z is positive for the first four quadrants. Second, sorry, octants. Second four octants, again you repeat same xx, xy, you repeat same plus plus, minus plus, minus minus, plus minus. Same, right? Exactly same. Repeat it and just put minus for the z. Then you will get 5, 6, 7, 8 octants. Okay, so remember this trick. This is very useful because at least in your NCERT or CBSE intermediate classes exams, you may get one or two at least objective type questions to find out which octant the point belongs to. Okay, so this is how you should do. Example, minus 2 comma 7 comma minus 1, it lies in. Okay, if you see here, minus 2 comma minus this one, right? Sixth octant. Now 3 comma 4 comma 5, it's first octant. So this is how we should do. This is the understanding of the octants and how to remember each octant number. Okay, next. Coordinates of a point. Okay, you are in a three-dimensional space, so obviously we will get a comma z, right? So normally you have x comma y. Now you will have x comma y comma z. Okay, so a point looks like something like 3 comma minus 2 comma 5. 3 comma 2 comma minus 5. Okay. So depending on the where the point is, in which octant the point is. Okay. Next. So yeah, this is what I'm explaining. Z is the distance from XY plane. Okay, this is the important thing is in this one. If if I give you a point in three-dimensional space, A comma B comma C or X comma Y comma Z. Okay. If I take Z, this is the distance from XY plane, whole plane itself. Correct? X comma Y is the point on XY plane. So Z is the distance of point. Z is the distance from XY plane. How high or how low is the from XY plane? Correct? Similarly, if I take Y is the distance from ZX plane. Okay, and X is the distance from YZ plane. This you need to understand very well. Okay, and on X-axis you will have point something like, on Z-axis you will have the point something like 0 0 comma Z. Y-axis you will have 0 comma Y comma 0. X-axis it will be X comma 0 comma 0. Okay, similar to the two-dimensional space. You just extended one more parameter there. Next. Yeah, distance in a three-dimensional space is very similar. Uh, you just get a z2 minus z1 whole square extra. So it is nothing but square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Okay, you can find out the distance between this one. It's nothing but 4 minus 1, 3 square plus 4 square plus 6 square. Okay, whatever is the number, right? Next. Applications of distance, where you can use distance, you can check the collinearity, identify triangle types, you can verify the rectangles and parallelograms and the locus problems. All these you can solve using the just simple distance formula. Correct? So remember this one. Let's get into, I think theory-wise, class 11th 3D geometry is very, very small part. Okay. Even though you can create multiple varieties of questions based on just distance. Okay. uh, but theory wise that's all. Okay, you need to now solve more problems to understand it more deeply. Okay, now let's do the exercise 1 11.1. Okay, a point is on x-axis. What are its y coordinates and z coordinates? We know if a point is on x-axis, it is 0 and 0. Y and z are 0 and 0, right? A point is on zy plane. Can we say that, what can we say about its y coordinate? If the point is on xz plane, then y coordinate is 0. So its y coordinate is definitely 0. Next. Name the octants in which following point lies. So I told you trick how to do. First assume that it is a two-dimensional space and put for positive and negatives for xy. Then you add first four quadrants, add only positive for the z quadrant, third quadrant, and then that you call it 1 2 3 4. Just repeat exactly. Only thing is z parity will be negative in this. Okay, so this is what I put the table here. You just use this one. It's very simple. You can do it yourself. I'll just take one of them. 4 comma minus 2 comma minus 5. 4 comma minus 2 comma minus 5. This is positive, negative, negative, positive, negative, negative. False here, eighth quadrant. Okay, positive, negative, negative, eighth quadrant, eighth octant. Sorry. Okay, so this is the eighth octant. Next. X-axis and y-axis taken together determine a plane known as xy plane. We know it. The coordinates of a point in the xy plane are in the form of a comma b comma 0, xy, right? Z is 0. Coordinate planes divide the space into 8 octants. We just saw the example there, right? So these are the problems in 11.1. And let's go to next 11.2. Find the distance between the following pair of points. Okay, so I'll do one of them. Rest all you can do. Okay, so you have x1, y1, z1 and x2, y2, z2. Distance formula is x2 minus x1 whole square, square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Okay, so this is how we should do. You can, I think these are the simple questions which you can do it yourself. Okay, show that the points are collinear. So this is similar to the problem which you normally do in the two-dimensional space. You find the distance between those two or the slope. Okay, as of now in this one we are not introduced to slope formula. So just check with the distance. So distance of group of 2 points, then sum of them will be equal to the third one. Okay, so distance between the first 2 points is square root of 14. Distance between second 2 points is first and third point is 3 root 14. Distance between second and third point is 2 root 14. Okay, so we can always see that square root of 14 plus 2 square root of 14 equal to 3 square root of 14. So they are collinear. Okay, so this is, yeah, not so linear, they are collinear. Next. Okay, verify the following. Okay, these are the 3 points which are given are vertices of isosceles triangle. So, for finding the vertices of for proving that 3 points are vertices of a triangle, you can take the distance between those 3 points. So you will get the three sides. Then apply the triangle rules basically. Okay, so distance between first two, second two, and 1 and 3 points is 3 square root of 2, 6, and 3 square root of 2. If you see, two of them are equal, right? 3 square root of 2, 3 square root of 2 are the two sides of a triangle which are equal. Third side is 6. So you need to apply one, not only the lengths of sides, but also you should check that whether these three lengths can form a triangle or not. So triangle rule is sum of two sides should be greater than the third side, correct? So if you check that, all conditions are possible. So this is a isosceles triangle. Next. Okay, verify these points are vertices of a right angle triangle. For right angle triangle, it is very easy. You just apply Pythagoras or 𝐸𝑑𝑖𝑐𝑒 theorem, right? So very simple. Find the three sides first, and then apply a square plus b square equal to c square. Okay, so it is obeying the Pythagoras or 𝐸𝑑𝑖𝑐𝑒 theorem. So it's a right angle triangle. Okay, now verify the following are vertices of a parallelogram. Okay, so how do you check? You can find definitely four sides, the lengths of four sides. So opposite sides will be equal, but they are equal for opposite sides are equal, and you will get two sets of lengths. Okay, two different sets of length. If all are equal, then it will become a rhombus, right? So check those points. But just to give you information, parallelogram can be checked by many ways. Okay, one is the lengths of the sides, opposite lengths are same. You can also say opposite angles are same. You can also say midpoints of the diagonal are same. Okay, you can also check if sum of neighboring angles is 180 degrees. You have four ways to prove that they are parallelogram actually. Okay, the easiest way is check the midpoints of diagonal. Okay, this is much easier than finding four sets of sides and then check the equality between those. Okay, so midpoints of A and C is 3 by 2, comma minus 5 by 2, comma 9 by 2. Midpoints of B and D also is same actually. Okay, that means midpoints of two diagonals is same, which means it can form a parallelogram. Okay, you take two lines, okay, exactly intersect them at the midpoints. Okay, then definitely you can form a parallelogram. You can also get a rhombus. Okay, but rhombus is a parallelogram anyway. All right, so this is definitely a parallelogram. Next. Find the equation of the set of points which are equidistant from these points. Okay, so this is like kind of a locus problem. So you will assume that the point is x comma y comma z. Okay, which is equidistant from the 2 points, and then you just apply the distance formula. Okay, so distance formula is square root of x1 minus x2 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So, and square it both sides, you will get a simple equation. Y minus 2 whole square gets cancelled on both sides, so don't consider it. Simplify it, you get the equation of locus of this point, which is nothing but x minus 2z equal to 0. Okay, next. Find the equation of set of points P, the sum of whose distances from these 2 points A and B is equal to 10. So what is trying to tell is if P is x comma y comma z, PA square, okay, sorry, PA plus PB equal to 10. That's what it's trying to tell. Okay, so this is very simple. Take PA and PB. If P is x comma x y z, then PA is nothing but this one, square root of x minus 4 whole square plus y minus 0 whole square plus z minus 0 whole square plus PB is this one, which is equal to 10. Now you just need to do simplification. First take one to the other side or same side, you square it. Okay, once you square it, you can cancel some of the terms. That's why we are taking one of them to the other side basically, because you can see y square and z square can be cancelled very easily. Okay, and simplified, you will get this locus very easily, which is nothing but 9x square plus 25y square plus 25z square minus 225. Okay, so important thing is whenever you see such equations and you're trying to find the locus or solving them, you should find the best way to take. How can I square it? Okay, those things you should know very well. Okay, so looking at this, you can tell, right? If I square it with these two square roots on the both the sides, then I still left with 2y square plus 2z square. Correct? That is a more complex thing to solve. So if you should be knowing all these tricks. Next. Yeah, now let's do the miscellaneous exercise for the class 11th 3D geometry problems. Okay. Three vertices of a parallelogram ABCD are given. Find the coordinates of the fourth vertex. Okay. So parallelogram we know already. Midpoint of the diagonals is same. So let's say D is x comma y comma z. Then correct. Midpoint of AC is A and C is this one. Okay, which is equal to midpoint of BD is, if I call D as XYZ, then this is the midpoint. Then you can compare x coordinate, y coordinate, and z coordinate by equating, right? So 3 minus 1 by 2 is 1. 1 is equal to 1 plus x by 2. Okay, which means x is equal to 1. Okay, and then y is equal to minus 2, z equal to 8. So my d coordinates are 1 comma minus 2 comma 8. This is my z coordinates. Okay, find the lengths of medians of the triangle with vertices a b c which are given. So how do you find medians? Median is a line which connects the vertex to the midpoint of the opposite side in a triangle, correct? So ad is a median. So BD, D is the midpoint of BC, E is midpoint of AC, and F is midpoint of AB. Correct? So first thing is find out the midpoints. Okay, then it is very simple. Midpoint D, E, and F I found midpoints. Okay. Next is length of AD, length of BE, length of CF. Okay, which is nothing but 7 square root of 34 and 7. Okay. So these are the length of medians of this triangle. Next. If the origin is the centroid of the triangle PQR with vertices given here, then find the values of ABC. Okay, how do you find centroid of a triangle? In a three-dimensional space, it is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, and z1 plus z2 plus z3 by 3, right? So I just simply take the x coordinates, sum them up, average it, uh, equal to 0 because origin is the centroid here. Okay, so the x coordinate of the centroid is 0, y coordinate is 0, z coordinate is 0. So you equate individually, you will get ABC. A is minus 2, B is 0, and C is, sorry, okay, I didn't write B here. B is, let's calculate. Okay, 2 plus 3b plus 14 equal to 0 because 3 will go to other side. So 3b equal to minus 16. Okay, sorry, it's there. Minus 16 by 3. Okay, this is B and C is 2. Okay, so these are the three values of ABC. Next. If A and B are the points given respectively, find the equation of set of points P such that PA square plus PB square equal to K square, where K is a constant. Okay, we have solved this similar problem in the 11.2 chapter. There at least it is not squares, it is distances, so we did squaring and all those things. So here it is very simple. Let P be XYZ. Okay, then PA square is nothing but x minus 3 whole square plus y minus 4 whole square plus z minus 5 whole square. PB square is this one, which is equal to K square. Now you simply expand and simplify. Okay, so what you will get is this is the one. Okay, 2x square minus 4x plus 3 plus 2y square minus 14y plus 2z square minus plus 4z plus 109, which is equal to k square. Okay, this is the locus of the points. Okay, so let us continue our 3D geometry session. Okay, let's get into class 12th, NCERT class 12th. This is 3D geometry because class 11th is very, very small information and very basics about 3D geometry. I thought I can combine both of them into one video. Okay, so this is definitely useful for both class 11th and class 12th as well as who are preparing for engineering entrance. Okay, so in this one we will learn direction cosines. What is the direction cosines? Direction cosine is nothing but if there is a line in 3D space and the angles it makes with x-axis, y-axis, and z-axis is called the direction cosines. Okay, if they are if the direction cosine of with x-axis, y-axis, and z-axis is lmn, then L square plus m square plus n square equal to 1. Okay, so let's learn this one more detailed. Okay. There are two concepts, direction cosines and direction ratios. What is direction ratios? This is what we normally represent a vector in 3D geometry. How we will represent v bar equal to a I cap plus b j cap plus c k cap. Okay. If this is your regular way of representing a vector in 3D space, then ABC are called the direction ratios. Okay. The terminology is important. This is direction ratios. And what is direction cosines? If you find a unit vector, okay, if you find a unit vector with respect to v bar, then this is those values are those coefficients of ijk are actually called direction cosines. Okay, if this vector v bar is making an angle of alpha, beta, gamma with xyz axis respectively, then cos alpha, cos beta, and cos gamma are called direction cosines. Okay, cos of this value is called direction cosines. But if do you know the angle given from this vector information? Not directly, so we have to do something. What we will do? We will find a unit vector b cap equal to li cap plus mj cap plus nk cap, nk hat basically, be the unit vector parallel to the given v bar. Okay, v vector. Then element are called direction cosines. Okay, if you write in this way, if you find the unit vector of this one, a main vector, then its coefficients are direction cosines. How do you get this one? Okay, and we know that b hat is a unit vector, which means L square plus m square plus n square equal to 1. Okay, now how do you get this element values? L is nothing but a divided by, okay, a divided by square root of a square plus b square plus c square, plus or minus we'll get. M is equal to plus or minus b divided by a square plus b square plus c square. Similarly, n, okay, equal to plus or minus c divided by a square plus square root of a square plus b square plus c square. Okay, so now there are definitely several questions based on this direction cosines and direction ratios, which we can solve. Okay, so direction cosines of a line passing through 2 points. If you are given 2 points in 3D space, okay, and we know that PQ, the distance between those 2 points is nothing but square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Now direction ratios are nothing but A is x2 minus x1, B is y2 minus y1, Z is z2 minus z1. These are my direction ratios because these are 2 points. If I write the line equation, I get x2 minus x1 I hat plus y2 minus y1 j hat plus z2 minus z1 k hat. Now, what are my direction cosines? Which is simple, right? Just we saw. So L equal to A by A is nothing but this value. A by PQ modulus PQ. M equal to M by PQ. N equal to C by PQ. Okay. Just for complete detailed formula here, L is equal to x2 minus x1 divided by square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Okay, this is the direction cosines of a line passing through 2 points, which is straightforward parallel. Yeah. And next, let's do chapter 11.1. Most of these questions are covered on direction cosines and direction ratios. Let's understand this more. Okay. If a line is making 90 degrees, 135 degrees, and 45 degrees with XYZ axis respectively, find its direction cosines. This is a straightforward question where you'll apply cos 90, cos 135, and cos 45. Okay. Next, find the direction cosines of a line which makes equal angles with the coordinate axis. Okay. So if they are making equal angle with the coordinate axis, and we know that L equal to M equal to N, which is equal to cos theta, and we know that L square plus M square plus N square equal to 1. So 3 cos square theta equal to 1 or cos theta equal to plus or minus 1 by square root of 3. So direction cosines are nothing but plus or minus 1 by root 3, plus or minus 1 by root 3, and plus or minus 1 by root 3. Okay. If a line has direction ratios minus 18, 12, and minus 4, then what are its direction cosines? Okay. Ratios are given. A, B, C are given. I need to find LMN. Okay, which is simple, right? If A, B, C are given, my line is nothing but minus 18I plus 12J minus 4K. Then L is nothing but minus 18 divided by the distance from origin of this point. If you consider this as 3 coordinate point, then distance from origin, which is square root of 18 square plus 12 square plus 4 square. Okay, that is minus 9 by 11. Similarly, M and N also I can find out. This is my direction cosines. Show that the points are collinear. Okay, so we have solved this problem in the class 11th chapter, I think, exercise 11.2, I think. Okay, uh, based on distance formula we solved. Okay, here we will use the direction cosines to solve it. Okay, so that's simple. Line passing through, you take any 2 points basically. Line passing through 2, 3, 4, and minus 1 comma minus 2 comma 1 is nothing but how I will do minus 1 minus 2, which is minus 3, minus 2 minus 3, which is minus 5, 1 minus 4, which is minus 3. So this is my line equation. These are the A, B, C. Okay, now I need LMN. Okay, because direction cosines always give me direction of the uh, direction and angle with the XYZ axis. So if both are same, then I can say that they are actually collinear. So LMN is nothing but these values. So if I simplify, I get minus 3 by square root of the 43, minus 5 by square root of 43, minus 3 by square root of 43. Now you take other 2 points. Line passing through other 2 points is also like first make the line equation, which is 6i plus 10j plus 6k. Okay. Then direction cosines of this line is nothing but 3 by square root of 43, 5 by square root of 43, and 3 by square root of 43. If I compare these two, only sign is different, values are same. What is the meaning of it? That means they are in opposite direction, that's all. But they are collinear. So with this also I can prove that 3 points are collinear. Yeah, next. Find the direction cosines of sides of a triangle whose vertices are given here. Okay, this is a straightforward question. You make three line equations. So that means they are the direction ratios you will get basically in ABC. And then you just make a direction cosines element of that one. Okay. So just let's see the first one. Equation of line A and B is this one. Okay. So direction cosines of AB is element, which is nothing but minus 4 by square root of 16 plus 16 plus 36, 4 square plus 4 square plus 6 square. Okay. Similarly, other two. So what I will get is minus 2 by square root of 17, minus 2 by square root of 17, and 3 by square root of 17. Similarly, you can do for AC and BC. Let us discuss about equation of a line in a 3D space. Okay. So this is very simple. If you see in two-dimensional geometry, equation of a line is ax plus by equal to c. Correct. So here also you will get something like that, similar to that. But only thing is, we will separate between the point and the direction. Okay, so that's the only difference, and you can represent in two different forms. Let's see both the forms. Okay, equation of a line in a space. A line in 3D is uniquely determined if it passes through a given point and given a direction. Only then we can represent it. Or it passes through two points. Okay, or you should get 2 points. Okay, so here how do you get the direction then? Difference of 2 points is the direction itself. Okay, if a1 a2 are the 2 points, a2 minus a1 is the direction of the line, correct? So these are the two ways we can represent a line in a 3D space. Now there is the two ways you can represent vector form and Cartesian form. In vector form you will have something like ax plus by plus cz. Okay, ax plus by plus cz. In this form we will get, only thing is the difference is, okay, the line through a given point and parallel to a vector. Okay, if a line is passing through a point A and parallel to vector b bar, okay, then r bar, this is the line equation in vector form, is equal to a bar plus lambda b bar, and the lambda can be any real number. What is the meaning of this one? Okay, lambda b bar means, so the line is passing through the point a bar, okay, and it is in the direction of b bar. So in the direction of b bar there is not only b bar, right? There can be lots of lines which are in the direction of b bar. All the parallel lines to b bar are in the direction of b bar. So you can actually say that a bar plus any line parallel to b bar, correct? That's why we represent using lambda. So in the question they may either give b bar directly with some values, or it's multiplied with some constant k or lambda, right? As I said, some integer value or some real value, they multiply and give, both are same actually. Okay, if it is given a plus b bar or a plus 5 bar, both actually represent same line. Okay, that is what you need to understand here. Okay, now in Cartesian form, suppose x1, y1, z1 is the point and the direction ratios are ABC for the b bar. Then uh, the parametric equations are nothing but x equal to x1 plus lambda a, y equal to y1 plus lambda b, z equal to z1 plus lambda c. And if I represent them removing lambda, it will become x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. This is equal to lambda actually. Okay, constant. All three are constant. So this is the equation of a line in Cartesian form. Okay, this looks very odd because so far we are looking at only equations where only one equal symbol is there, but here there are two equal symbols. Okay, that's the only difference. Otherwise, rest all is same actually. Okay, so this is the Cartesian form of the equation. There are advantages of using both depending on the problem actually. So which we'll see. Okay. So if LMN are the direction cosines, then In Cartesian form, the equation will become x minus x1 by L equal to y minus y1 by M equal to z minus z1 by N. Okay. So if you see here, the numerator contains the point here, denominator contains the direction. Okay. So L, M, N are the directions. Direction cosines are nothing but directions only. They are also parallel to the B bar, but just unit vectors. That's all, right? So you can actually say represent the line equation using this one also. Okay. Line through 2 points is nothing but if A bar, B bar are the 2 points, then you take any point A bar because it is passing through A bar plus lambda B bar minus A bar, which will give you the direction, right? So here lambda belongs to R again. Okay. So this is the vector form, and if you want in Cartesian form, it will become x minus x1, or you can take x2 also. Okay. Here also you can take B bar, doesn't matter. Okay. X minus x1 divided by x2 minus x1. This is where you get the direction of x. Okay. Direction of y, direction of z. Okay. So x minus x1 divided by x2 minus x1 equal to y minus y1 divided by y2 minus y1 equal to z minus z1 divided by z2 minus z1. This is the Cartesian form of the line equation, given that the line is passing through 2 points, x1, a1 and b1, or whatever you can say, right? Yeah. Next, angle between two lines. Okay. So this is also a very interesting one, slightly again different from two-dimensional geometry. Okay. And we can also derive the conditions which are perpendicular, parallel, all these conditions we can derive. So let's see. Okay. So lines through the origin, okay, are not, it doesn't matter actually. And let two lines have direction ratios A1 B1 C1 and A2 B2 C2. These are the direction ratios of two lines. So if I represent them in a vector form, it will become let's say A1x plus B1y plus C1 Z, A2x plus B2y plus C2 Z. Okay. Now angle between these two is, okay, angle between these two lines is cos theta equal to modulus of a1 a2 plus b1 b2 plus c1 c2 divided by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. Okay. So this is the cos theta of angle between two lines. Okay, where you are given the direction ratios. Okay. If the direction cosines are given, you can still do same actually. Only thing is it will become square root of L1 square plus M1 square plus N1 square is 1. So this will become 1. This also will become 1. L2 square plus M2 square plus N2 square also will become 1. So you will not have any denominator. You will just have numerator, which is L1, absolute L1 L2 plus M1 M2 plus N1 N2. This is the angle between two lines, right? So remember what you are given. It doesn't matter actually. It's almost same. Even if you calculate this, you will get 1 only. Okay. So now, what is the condition for perpendicular? They should be equal to 0. Cos theta equal to 0. So that means denominator is gone. So you will be left with a1 a2 plus b1 b2 plus c1 c2, which should be equal to 0. This is the condition for perpendicular. Okay, this is equal to 0. I'm missing here actually. Okay. If they are parallel, you can derive actually cos theta equal to 1. It will go to other side. You can derive it very easily. a1 by a2 equal to b1 by b2 equal to c1 by c2. This is the condition for uh, parallel. Okay. Now, if the lines are given in vector form, like r bar equal to a1 bar plus lambda b1 bar, or other line is r bar equal to a2 bar plus mu b2 bar, then cos theta is nothing but b1 dot product with b2 divided by absolute b1 and absolute b2. Okay. So now if you compare this with this, it is actually same. If you see b1 bar and b2 bar, okay, and these are the direction cosines here, a1 b1 c1, a2 b2 c2 are direction cosines. Okay, so that means the dot product will give you a1 a2 plus b1 b2 plus c1 c2, right? If you remember the vectors, this is what you will get. And what is absolute b1 bar? Is nothing but square root of a1 square plus b1 square plus c1 square. This is a modulus. And b2 absolute b2 is nothing but square root of a2 square plus b2 square plus c2 square. So it is actually same, exactly same. But one thing you can understand from this one is in vector form. What you can understand is, okay, cos theta equal to b1 bar dot b2 bar divided by absolute b1 bar absolute b2 bar. Okay, there is no mention of a1 and a2 here, right? There is no mention of a1 and a2. That means it is independent of points it is passing through. It depends only on the cos theta, or angle depends purely on the direction vectors, not on the position vectors. Okay, this is the very, very important information to note down. Okay, next. Yeah. Now let's understand the shortest distance between skewed lines. What is skewed line? First, we'll understand. Okay, unlike in 2D geometry, 2D geometry, two lines can either be parallel or intersecting, right? There is no other option. But in 3D geometry, two lines can be neither parallel nor intersecting. They can be skewed. What is this skewed? Okay, let's how to understand this. If you understand from this diagram here, cube diagram here, the red line here is on one of the plane. The second red line is on the opposite plane. Okay. If you imagine you are in a room, on the floor you drew a line. Okay, and on the uh, floor and ceiling. Okay, ceiling you drew one line, and the floor you drew another line. Do you think those two are parallel? Okay, they need not be parallel, right? Unless until they are in the same direction, then they are parallel. But otherwise, they need not be parallel. But are they intersecting? They are not intersecting. They never intersect. These two lines also will never intersect, and they are not parallel. These are called skewed lines. And what is the distance between these two? It's nothing but distance between the two planes. Correct? Distance between the two planes is the distance between these two lines. Okay. So in 3D geometry, you will have distance between skewed lines. Okay. And how to do this? Let's see. Skewed lines are the lines not parallel, not intersecting. They are in two different planes. Okay, so let's say L1 equal to A1 lambda B1. L2 is nothing but A2 plus lambda B2. Okay, or you can say mu here, no problem. Shortest distance equal to A2 minus A1 dot product with B1 cross B2. A2 minus A1, you get a vector here, right? And B1 cross B2 also you get a vector. Okay, dot product of these two divided by absolute B1 cross B2. Okay, so this is the cross product here, two are the cross product here. So here basically you are getting a unit vector. If you see here, if b1 cross b2 is some vector you are getting, dividing with the modulus of that same vector, it will give you unit vector. That means you are getting a direction here. Okay, you are doing the a dot product with the direction, and a2 minus a1 is position difference, right? So let's see what is this. Okay, so a2 minus a1 is nothing but the distance between 2 points on two lines. Okay, b1 cross b2 divided by absolute b1 cross b2 gives you the vector perpendicular to both directions. Okay, unit vector perpendicular to both directions. Okay, now this dot product will give you projection of a2 minus a1 onto this unit vector. How to understand this? Let's say these are the two lines. Okay, L1 and L2 are the lines, and I am calculating distance, skewed distance between these two, which is nothing but shortest distance is, let's say, P comma Q has the shortest distance. Not every 2 points will have shortest distance. Okay, they should be perpendicular to the planes. Then only you get the shortest distance. So let's assume that PQ is the shortest distance. Okay, now I am given the line equation A1 and A2. I am not given PQ. I need to find out PQ actually where it is short. But I know the A1, A2 and I have the direction. Okay, so what will happen is B1 cross B2, B1 cross B2 will give me a vector which is perpendicular to these two planes. Okay, which is this perpendicular to both of them, right? In the direction of PQ only. Okay, now divided by, of course, b1 cross b2, because I need only unit vector. I don't need to multiply this pq with something else. I need only just unit vector. Okay, so I got the b1 cross b2 divided by absolute b1 cross b2. I got the unit vector which is parallel to pq. Now a2 minus a1 is nothing but this line. Now if I see the projection of this line onto this unit vector, I get the shortest distance, which is pq. Correct? That's what is I'm doing here. I'm taking the distance between 2 points, projection of this one onto the unit vector, which is in the direction of PQ, or the shortest distance. Okay, so this is how you will calculate the distance between the skewed lines. Okay, so hope you understand these basics. You have three things. One is angle between them, line equation, and the distance between them. These are the three topics, but you can create n number of questions based on these actually. Okay, and very interesting questions. In NCERT and you are probably 11th and 12th, you may not get a very tough questions, but JEE or any other engineering entrance exam, you will definitely get very tricky questions based on these concepts. So you have to understand the concepts very well. Go through the NCERT book, go through your state syllabus books. Okay, so that will give you the idea of how these things are derived. Okay. Now, distance between skewed lines if they are given in the Cartesian plane. Okay, they are given L1 is given in a form of Cartesian line. Okay, L2 and L1. Now, A2 minus A1 dot B1 cross B2. A2 minus A1 cross B1 B2 is nothing but this value. Correct? Now I just need to Now I just need to divide this with absolute B1 cross B2. That's all. All right. So this is how we'll do. This is a shortcut for you just to tell you how to get the. You don't need to do A2 minus A1, then B1 cross B2 separately, and then do dot product. You don't require to do. You can do this way actually. Okay. This modulus will give you uh, the A2 minus A1 dot B1 cross B2. It will give you. Okay. Now let A1 lambda b and a2 lambda b because they are parallel lines because the directions are same b1 bb. Okay, then shortest distance will become, you don't need to do the cross product now. Okay, you just need unit vector, so you will make it b bar by absolute b bar. Okay, then this is the shortest distance between two parallel lines. Okay, formula is exactly same. You are basically reducing the mathematical calculation. That's all. Okay. If L1 and L2 are coplanar and not parallel, what is the meaning of this? That means they are intersecting. Okay. And the condition for intersecting is A2 minus A1 dot B1 cross B2 equal to 0. Okay. This will become 0. Then they are uh, intersecting. Basically, they are coplanar and not parallel. Okay. So the condition for this one is very simple. X2 minus X1 position vectors, Y2 minus Y1 and Z2 minus Z1, and then A1 B1 C1 A2 B2 C2. Okay, so this is how you will do. Yeah, next. Let's do the exercise 11.2 now. Show that the three lines with direction cosines given here are mutually perpendicular. What is the condition for mutually perpendicular? A1 A2 plus B1 B2 plus C1 C2 equal to 0. So you take any two lines here, okay? Any two lines here, and then they're given direction cosines directly. So they are nothing but A1 B1 B2, A2 B2 C2, and A3 B3 C3. So you take any two lines and just calculate the A1 B1 plus A2 B1 B2 plus C1 C2. That's it. Okay. So this is my L1, this is my L2, this is my L3. I need to check this condition. So take two lines and check the condition. It is 0, 0, and 0. So all three are perpendicular to each other, which means they are mutually perpendicular. Okay. Next. Show that the line through the points 1 comma minus 1 comma 2 and 3 comma 4 comma minus 2 is perpendicular to the line through the points 0 comma 3 comma 2 and 3 comma 5 comma 6. So they gave 2 points for each line. So I can construct two line equations easily, right? And then check perpendicular condition again from the direction cosines. Okay. So equation of line passing through the 2 points, this first 2 points is this one. Okay, I just kept 1 comma minus 1 comma 2, but yeah, you should write 1i minus k plus minus j plus 2k. Okay, plus lambda 3 minus 1. Okay, this is the difference between 2 points. Okay, 3 minus 1, which is 2i plus 5j minus 4k. Okay, so this is my line equation. Okay, and for similarly for L2, this is my line equation where I am interested only in B1 and B2. So these are my B1 and B2s. So the cos theta should be equal to 0 for perpendicular conditions. Cos theta is nothing but B1 dot B2 divided by absolute B1 into absolute B2. So check the conditions. Since you are anyway checking for perpendicular condition, just you will tell whether they are perpendicular or not. You need not tell the angle between them, right? So I need to just check the numerator condition. Numerator, the dot product should be equal to 0. Okay. So I took B1 dot B2. So there is nothing but 2 into 3 plus 5 into 2 minus 4 into 4, which is 0 anyway. So that means theta is 90 degrees and the lines are perpendicular. Next. Show that the line through the points 4, comma 7, comma 8 and 2, comma 3, comma 4 is parallel to the line through the points, other 2 points. Now we are same question as last. I'm checking for the parallel condition. So first form the lines. Okay, two lines you form, then check the cos theta condition. Okay, here you are checking for not 0. So definitely you need to worry about absolute B1 and absolute B2 here. Okay, so this is again dot product of the direction cosines, these two. Okay, which is nothing but minus 2 into 2 plus minus 4 into 4 plus minus 4 into 4 divided by absolute value of this one and absolute value of this one, which is nothing but 36. Okay. So if I see this is coming -1, cos theta equal to -1 means theta is equal to 180, which means that lines are parallel, just they are in opposite direction. That's all. Okay. Next. Find the equation of the line which passes through the point 1, 2, 3 and is parallel to the vector given. Okay, this is a straightforward question. You have a point, you have a vector which is parallel. So you can just add lambda in front of this vector. Okay, lambda you add in front of this one and then add this one. That's it. Simple. Okay, so I plus 2j 2j plus 3k plus lambda times 3i plus 2j minus 2k. This is what the equation of the line which we are looking at, where lambda is a real number. That's it. Okay. Find the equation of the line in vector and in Cartesian form that passes through the point with the position vector 2i minus j plus 4k and is in the direction of I plus 2j minus k. Okay, this is a straightforward question for vector form. Okay, vector form is very straightforward. Okay, I just put this one and the lambda times the direction. Okay, where lambda is the real number. And Cartesian form, how to write? Let's see. Okay, so you take the position vector information goes into the numerator, direction vector goes directly into the denominator. Okay, so position vector here x coefficient is I coefficient is 2, so x minus 2 we'll say, x minus 2 divided by 1 is the I coefficient here. Okay, of the direction vector. So x minus 2 by 1 equal to y plus 1, because it is minus 1 here, y plus 1 divided by 2 equal to z minus 4 divided by minus 1. Okay, this is my Cartesian form of the line. Okay, hope you understood how to form the Cartesian form of the line. Next, find the Cartesian equation of the line which passes through the point and parallel to the given line given by this one. Okay, so here I can actually get the direction vector from these three. So this is nothing but 3i plus 5j plus 6k is my direction vector and this is my position vector. Then I can form a line easily. Okay, or straightforward, I just replace these position vectors with my position vector. That's it, right? I am replacing plus 3 with plus 2, okay, and minus 4 with minus 4, plus 8 with plus 5. I replace, then I will get the required line equation. That's it. Okay, you can do it in a plus 2 if you are doing basically board exams you are writing, you have to do little uh, elaborately. So you get the direction vector from these 3 points and then build a vector form or Cartesian form of the line equation using position vector as well as direction vector. Okay, but this is what the straight way. Okay, next. The Cartesian equation of a line is x minus 5 by 3 equal to y plus 4 by 7 equal to z minus 6 by 2. Write its vector form. Okay, this is very simple. Okay, straightforward. These are my positions. So it will become 5i minus 4j plus 6k plus lambda times 3i plus 7j plus 2k. That's it. Okay, where lambda is the real number. Next, find the angle between the following pair of lines. Okay, so they are given two pair of lines, and for angle rule is nothing but cos theta equal to b1 dot b2 divided by b1 absolute b1 into absolute b2, or modulus b1 modulus of b2. Okay, so here cos theta equal to, I have to take only the b1 and b2. Okay, angle depends only on the direction vectors. So dot product of these two divided by modulus, their modulus, respective modulus of their direction vectors. So here 3 into 1, which is 3, 2 into 2, so plus 4, 6 into 2 plus 12 divided by 7 into 3 modulus. So 19 by 21. So theta is equal to cos inverse of 19 by 21. Okay, next. Again, two other sets are given. You will do exactly same way. Okay, just do it yourself. Find the angle between the following pair of lines. Okay, here they are given in the Cartesian form, not in the vector form. So first you convert into Cartesian form, very simple. Okay, and then do it same thing. Or you already know this is the direction vectors, so you can do it yourself directly substituting in cos theta. Okay, so if you see here, 2 plus 2i plus 5j minus 3k dot with minus I plus 8j plus 4k, right? Divided by their modulus. Okay, so here theta is equal to cos inverse of 26 by 9 root 38. Okay, so always whether you are when you are getting such value, Please cross check. How do you know this correct value or not? One way to cross check is whether cost value is always within -1 to 1. Correct? -1 to 1. So whether this value is between -1 to 1, that you cross check. Then you know that at least you are sure that okay, your calculation is correct. Okay. Next, similar, same another set is given. You can do it exactly same way. Okay. Find the value of p so that the lines 1 minus x by 3 equal to 7 by minus 14 by 2p equal to z minus 3 by 2 and 7 minus 7x by 3p equal to 5 y minus 5 by 1 equal to 6 minus z by 5 are at right angle. Okay, what is the condition for right angle? A1 A2 plus B1 B2 plus C1 C2 equal to 0 and they comes from this value. Correct? So that's all you need. Okay. So 3 into 3p. Okay. Only thing is, before doing that, you should write in proper form actually. Okay. You should write in, this is not x minus 1. This is 1 minus x. So you should actually write in proper way, which is nothing but x minus 1 divided by minus 3 it is. Okay. Equal to, this is 7 minus 14. So divided by 7 you do, so y minus 2 divided by 2p by 7. Okay, which is equal to z minus 3 by 2, which is same. And second one is x minus 1 by minus 3p by 7 divided by minus 3p by 7, which is equal to y minus 5 by 1, which is equal to z minus 6 by minus 5. Okay, this is very important. Okay, the equation, Cartesian equation should be always in the form of x minus a, y minus b, z minus c. Okay, it cannot be in the form of a minus x or b minus y or c minus z. Okay, first write it in the proper condition. Now you know that which are my b1 and b2. My b1 and b2 are, this one is b1, here it is b2. Now I just need to do dot product. That's why minus 3 into minus 3p by 7 plus 2p by 7 into 1 plus 2 into minus 5. Okay, this is nothing but um, 11p by 7 minus 10, which is nothing but p is equal to 70 by 11. Okay, so do this carefully. This may be the normal question which will come in your board exams. Simple trick, simple and tricky, but it's very normal. You will get similar questions in board exams. Show that the lines x minus 5 by 7 equal to y plus 2 by minus 5 equal to z minus 1 and x by 1 equal to y by 2 equal to z by 3 are perpendicular to each other. Again, they are in the proper form. So you just need to take b1 dot b2. Okay. So 7 into 1, correct? 7 into 1 is 7. Minus 5 into 2, minus 10. 7 minus 10 is minus 3. Minus 3 plus 1 into 3, 3. Minus 3 plus 3, which is equal to 0. So they are perpendicular. Simple. Find the shortest distance between the two lines given here. So we already know the formula for shortest distance, which is nothing but absolute A2 minus A1 dot product with B1 cross B2 divided by modulus of B1 cross B2. Okay. So to get the A2 minus A1 dot product with B1 cross B2, we can use this modulus. Okay. You can use this determinant det actually, which is nothing but x2 minus x1, y2 minus y1, z2 minus z1, then a1, b1, c1, a2, b2, c2. Okay. So here x2 minus x1 is nothing but you take these two, 2 minus 1, y2 minus y1 is minus 1 minus 2. Okay, z2 minus z1 is 2 minus 1. Sorry, minus 1 minus 1. Okay, so this is my first row, and the second row it will directly come from here, which is 1 minus 1 1. Okay, and the third row will come from this one b2, which is 2 1 2. Okay, now if you find out the value of this one determinant, then it is nothing but 9. Okay, then the bottom is I need to find out the modulus of b1 cross b2, which is nothing but b1 cross b2 I will get from the determinant here ijk. Okay, replace ijk in the first row, you will get it. So that is nothing but minus 3j plus 3k. So its modulus is 3 root 2. So shortest distance is 9 divided by 3 root 2, which is 3 by root 2. Okay, hope you understand. This is the first calculation we are doing for the shortest distance. So I think do it carefully. Next. So now it's the same thing. They are given the equation of lines in the Cartesian form, and you need to find the shortest distance, which is same, right? So formula is same. So how to write this one? X2 minus x1 I need, right? So I will take, okay, 1 here, 1 minus of minus 3, which is plus 3, 1 minus of minus 5, plus 5, 1 minus of minus 7, which is plus 7. Okay, this is my first row, and second row I will take as is B1 and B2 third row. So modulus of this one is 116. Then B1 cross B2 is nothing but minus 4i minus 6j minus 8k. Okay, how did you get this? ijk in the first row and 761 and 1 2 1 7 minus 6 1 in the second row, 1 minus 2 1 in the third row. That's it. Okay, so the modulus of B1 cross B2 is 116. Okay, so the shortest distance is square root of 116. If I simplify, I'll get 2 square root of 29. Okay, hope this is correct. It looks something very odd for me actually. If I take divided with 4, it will become 4 to the 8. Yeah, 29. Correct. This is correct. 2 square root of 29. Okay, next. Find the shortest distance between the two lines which are given here. I think it's a straightforward question. Okay, you can do it yourself. Okay, just to substitute the values a2 minus a1 dot b1 cross b2, and then find out the b1 cross b2 and modulus of it. Okay, it's a straightforward question. You can do it yourself. Okay, find the shortest distance between r equal to 1 minus ti plus t minus 2j plus 3 minus 2t k, and second line is s plus 1i plus 2s minus 1j minus 2s minus 1k. Okay, the way they given the equation is very different. But only thing is you write it separately in the position vector plus lambda direction vector. Okay, how do I write it? See this one. This is the given vector, first one. R bar line is, so I am writing it as I, okay, minus 2j plus 3k. Okay, plus t times minus I, okay, plus 1 plus 1j, okay, and plus 2k minus 2k. So okay, so now this is in the form of real line vector, where we are normally look at the line vector, right? Position vector plus lambda times direction vector. Okay, similarly second line also you write it, you will get the position vector plus s times direction vector. Okay, now this is my a1, this is my a1, this is my a2, this is my b1, this is my b2. That's it. Substitute everything, rest all is same. You find the a2 minus a1 dot product with b1 cross b2, and then you find the absolute value of b1 cross b2, then divide them, you get the shortest distance as 8 divided by square root of 29. Okay, next. Yeah, that's all. Exercise 11.2. Now let's do miscellaneous exercise which is given here. Okay, find the angle between the lines whose direction ratios are ABC and B minus C, C minus A, and A minus B. Okay, so this is very interesting. They are given in very different way. Okay, so what is given is r1 is equal to, they are not given the position vector, only they gave lambda direction vector which is abc. R2 also direction vectors is b minus c, c minus a, and a minus b, and these direction vectors are enough for me to calculate the angle between the lines, correct? Because I just, what I need is cos theta equal to b1 dot b2 divided by modulus of b1 into modulus of b2, correct? And I will write it ai plus bj plus ck plus b minus ci dot with b minus ci plus c minus aj plus a minus bk. Okay, so if I do the dot product, I'll get a times b minus c plus b times c minus a plus c times a minus b, and I don't need to worry about my denominator, okay, here, because if I see the numerator, I'm getting 0. Each term cancels other, I'll get 0. So theta is nothing but 90 degrees. They are perpendicular. Okay, next. Find the equation of a line parallel to x-axis and passing through the origin. Okay, so this is a simple one. If the line is passing through the origin, the point in space is 0 comma 0 comma 0, right? And unit vector parallel to x-axis is nothing but I plus 0 j plus 0 z. Now required equation in parametric form is, or vector form is, r is equal to uh, basically everything is 0 plus mu of I. Okay, and Cartesian form is x by 1. That's all. Only thing remaining is x by 1, which is equal to y by 0 equal to z by 0. Okay, one important note is, whenever you write in Cartesian form, when 0 comes in the denominator, it does not mean that infinite, not dividable. I mean, don't assume that this is a undivided number. Okay, so you should not write it. Y by 0 doesn't exist, not defined, so don't write it. That is wrong actually. This is nothing to do with division actually. This is a representation of Cartesian form of a line. Okay, so it is x by 1 which is equal to y by 0. You have to write y by 0 equal to z by 0. This will tell us what is the direction. If I don't write this one, I don't know what is the direction of y and z. Correct? Y and z coordinates of the direction I don't know. So you should write it. Okay. Next, if the lines are perpendicular to each other, find the value of k. Okay, so we have done these problems before. Only thing is just make sure that the format is correct. X minus 1, y minus 2, z minus 3, x minus 1, y minus 1, z minus 6. They are in the right form. So I am interested only in this b1 and b2, dot product of those two. Correct? So dot product, that one is nothing but minus 9k plus 2k minus 10 equal to 0, or k is equal to minus 10 by 7. Okay, next. Find the shortest distance between these two. We have solved this problem before. Shortest distance, okay, is nothing but a2 minus a1 dot products with b1 cross b2 divided by absolute or modulus of b1 cross b2. Okay, straightforward question. You can do it yourself. Find the vector equation of a line passing through the point and perpendicular to the lines. Two lines are given here. Now, how to find the perpendicular line to the given lines? Okay, so you should remember your vector algebra. Okay, in vector algebra, if two vectors A and B are given, the perpendicular line is always A cross B. Correct? And I am interested only in direction. I am not. Don't even worry. I am not worried about the modulus. Okay, so if this is my B1, this is my B2. B1 cross B2 gives me the direction of the direction perpendicular line which is perpendicular to these two lines. Correct? So that is what I am interested in. Okay, so line perpendicular to two lines is given, can be obtained by b1 cross b2. So b1 cross b2 is this one, ijk 3 minus 16 7 3 8 minus 5. Okay, now that is nothing but this value. I don't need to worry about the B1 cross B2 modulus actually, but I just want to calculate and show you what happens. Okay, so this is nothing but 24i plus 36j plus 72k, and modulus is 84. So line passing through 1, 2, minus 4 and in this direction is nothing but, okay, r bar equal to 1 I plus 2j minus 4k plus lambda times this value divided by 84. So I don't need to worry about this constant. I can actually remove, take 84 inside lambda and just still call it a constant. And I can also take 24 out, because 24 is common in this. 24 times 1, 24 times, I mean, uh, 12 times 2, 12 times 3, and 12 times 6. So I can write in a very simple form as r bar equal to I plus 2j minus 4k plus lambda times 2i plus 3j plus 6k. Okay. So always check in your answers. Probably they may not have given this in the options ABCD. They would have given this one, right? So you always cross check, because this can be any number, right? This you can multiply by 2 and keep it, multiply by 10, multiply by minus 10, multiply by 2 by 5, anything you can keep it here, right? So just cross check this one. That's why I choose this question. Okay, hope you understand this one. I think that's all from the 3D geometry. It is fairly simple one. 4 5 concepts are there. If you practice, I think you should not miss any of them. You should score 100% in this, at least in the boards. Okay, thank you. Keep doing maths. I'll come up with more lessons.